Yes, answers. See, a plane EM wave of frequency 25 megahertz travels in free space along the x-axis. At a particular point in space and time, electric field is given. You have to calculate the magnetic field. See, in the last class only, I told you a formula 6. If this is 6.3 J cap in Newton per Coulomb. Why J cap? Because it is given in the question. Why 6.3? This entire data is mentioned in the question. When we are talking about the speed of light is 3 into 10 to the power 8 meter per second. What is magnetic field? So there was a relation C is equal to E by B. From here, magnetic field will be equal to electric field divided by speed of light. So magnetic field will be 6.3 divided by 3 into 10 to the power 8 joules Tesla. All right. So this will be, I think, 2.1 into 10 to the power minus 8 joules Tesla. This will be the exact value. Write it down. One more question we will see. Question I hope you have written. Second question I'll show you. First, write down the answer to this. See, this says that magnetic field in a plane EM wave is given by By is equal to 2 into 10 to the power minus 7 sine 0.5 into 10 to the power 3x plus 1.5 into 10 to the power 11. You have to find out wavelength, frequency, and expression of electric field. See, By is 2 into 10 to the power minus 7 sine 0.5 into 10 to the power 3x plus 1.5 into 10 to the power 11 t. So when we write the when we compare it with the main equation, B is equal to B naught sine kx plus omega t. Can you see this is k, this is omega, and this is B naught. These are the things that we can extract from this question. Now see, first wavelength. You know k is 0.5 into 10 to the power 3. K is equal to 2 pi by lambda. So from here, lambda is equal to 2 pi divided by k. So lambda is equal to 2 pi, 3.14 by K. K is 0.5 into 10 to the power 3. This you can calculate. This much meters. Second part, no, in the same part only you have the frequency. So 2 pi nu is equal to omega. Frequency is equal to omega by 2 pi. Omega is 1.5 into 10 to the power 11 from the question. This is 2 into 3.14. So this much hertz will be in meters. This will be in meters, this will be in hertz. Now coming to the second part. C is equal to E naught by B naught. E naught is equal to C B naught. So speed of light is 3 into 10 to the power 8. B naught is given as 2 into 10 to the power minus 7. So this equals to 60 Newton. We are calculating speed of light, no? We are calculating, this is electric field, right? This is Newton per Coulomb. So when you have to write down the final equation of EY, this will be 60 sine. Why 60? Because this is the magnitude which we have calculated and obtained. 0.5 into 10 to the power 3x plus 1.5 into 10 to the power 11 t, this much of Newton per Coulomb. This is how you have to solve all the questions of EMB. Is this clear? Compare it with the main equation which you have. This was the main equation like this. See, once you have this, you have all the information. You have this with you, you have this with you, you have this with you. And with these three information, rest of these could be calculated. Write it down quickly, then we'll start with Maxwell's displacement current. Okay, now talking about Maxwell's displacement current. So there was an experiment done. These were the two ends of the capacitor place. We have discussed capacitors. Remember, parallel plate capacitors were there, cylindrical capacitors were there, as well as spherical capacitors. So these are spherical capacitors. Spherical plate, these are more, rather than spherical, you can say circular capacitors. So two loop areas were selected. This was one area that was selected. So here current was flowing, right? So when we apply Ampere's circuit law B dot dl, we get mu naught I, right? Second, we have chosen a space in between them where no current is flowing. So now when we'll take B dot dl, this will be equal to 0, mu naught into 0. So what are we getting? We are getting B dot dl closed integral is equal to 0. This is inconsistent with the Ampere's circuit law, because an Ampere's circuit law is only this part. We have to make it consistent with Ampere's circuit law. This is not matching with Ampere's circuit law. So the result of Maxwell is inconsistent with the Ampere's circuit law, right? So there Maxwell gave that if a displacement current is added to the conduction current which is flowing, C means the conduction current. D is the displacement current. So this is the current which is added along with the conduction current to find out the resultant net enclosed current. So this is that current. We write now mu naught is equal to I enclosed. So this is that I enclosed current. Value of displacement current, let me tell you this. This is epsilon naught d phi over dt. Phi is the flux, epsilon naught d phi over dt. Fine. Now, displacement current is what? Displacement current is, it is that current that comes into existence in addition to the conduction current whenever electric field and flux change with respect to time. So now your total enclosed current is the sum of conduction current plus the displacement current. All right, conduction current plus displacement current. So what will your ultimate formula become? And why are we saying this is consistent? How can we say, see, now when I'll write B dot dl closed loop integral is equal to mu naught IC, I can write this as epsilon naught d phi over dt. This is the formula which you will be using. Now one thing, d phi, this is already dq over epsilon naught. Which law is this? Phi is equal to q by epsilon naught. Which law is this? Some theorem is this? Is it some theorem, some law? Yes, Aliza? Which law is this? Phi is equal to charge by epsilon naught. Sidra? Which law is this? Phi is equal to q over epsilon naught. Amna? dq by epsilon naught is d phi. Yes, Aliza, Sidra, Amna, 3 students have called the name. You are present in the class? Yes, no?
Yes, ma'am.
Other students? Yes, so what's the answer? Deborah, which law is this? Without this law, why you people are studying even this lesson? Phi is equal to q over epsilon naught. Are you not able to recall this?
Faraday's law.
No, someone else? Fadil? This is Gauss.
Gauss law, ma'am.
This is Gauss theorem. Simple Gauss law. This is Gauss law says that the total flux enclosed within a closed sphere is 1 by epsilon naught times the charge enclosed. How can you people not answer this question? There is no point of studying this lesson even. We are heading towards the completion of syllabus and you're not aware about the Gauss theorem. Now I have to start taking your viva if this is the scenario. At least Gauss theorem basic things you should have answered. I didn't even ask the Ampere circuital law which was used above. B dot dl is equal to mu naught I. This is the law. So mu naught, if I'm talking about this, mu naught, this is epsilon naught, right? This is epsilon naught, mu naught into this. What is d phi? D phi is dq over dt, right? dq over dt. And then this phi, it is epsilon naught. Instead of this phi, I am substituting the value dq over epsilon naught, and epsilon naught dt were already there. Understood or not? Let me rewrite this. Epsilon naught by dt. This was already there. Instead of d phi, I am writing dq over epsilon naught. Epsilon naught will be cancelled. Can you answer this at least? What is dq over dt? What is dq over dt? Charge by time. What is charge by time? dq over dt. Current. Good. This is current. That is I. So here this is becoming back to B dot dl is equal to mu naught I. That is, it is now consistent with Ampere circular. This is the proof. If a question comes, prove that adding displacement current makes the law consistent, then you have to show this part. This small derivation, very small derivation, this you have to show. And that's why we have this displacement current in our system. Write it down. Okay, class, there are some properties of the displacement current. Whenever there's a change in flux, there will be a displacement current produced. That I have told you, the changes in flux will produce changes in electric field. And since electric field was changing, since potential was changing, there was a need of current, additional current. So that's why this will produce. Second was that it produces magnetic field. Displacement current, like the conduction current, produces magnetic field. And through the formula only, I told you, because of Gauss theorem, displacement current is directly proportional to the magnitude of the charge. This means this does not depend whether the charge is positive or negative. So magnitude of displacement current is equal to rate of displacement of charge from one capacitor plate to another. And lastly, it satisfies the property of continuity, means the way every current is continuous within the flow of wire. Same thing is with displacement current as well. Okay. One question, a parallel plate capacitor has circular plates, each of radius 5 centimeters. It is being charged so that electric field in the gap between its plates rises steadily at the rate of 10 to the power 12 volt per meter per second. What is the displacement current? So see, dE over dt is given. Volt per meter tells us that this is electric field. Per second gives us the information that this is time. Understood? Through this you have, if you have confusions, this you can solve. This is time. So dE over dt is equal to 10 to the power 12 because this is the rate of change of electric field. Understood? Right? And radius is given to us as 5 into 10 to the power minus 2 meters. So when we are calculating the displacement current, ID is equal to epsilon naught d phi over dt. So this is epsilon naught d EA over dt. This is equal to epsilon naught A dE over dt. dE over dt we already have. Why EA? Because flux is equal to EA. Now substitute the values. Displacement current will be 8.85 into 10 to the power minus 12. Area will be pi r square. That is 5 into 10 to the power minus 2 whole square. And what is dE over dt? 10 to the power 12. So this will be around 6.94 into 10 to the power minus 2 amperes. Or directly you can write the answer as 0.07 amperes. This is all about EM waves. Quickly write it down. So now we are left with modern physics. We have started with, okay, dual nature is left, that we are doing. And one wave optics is left. So by the next week, we should be able to complete the syllabus. I want to start with revision classes properly because many of you have not attended the initial classes also. Quickly write it down. Just keep on updating me in the chat column. Okay, if you all have completed, you can leave. This is over. So in the next class only, I think a longer class I'll take so that wave optics also gets completed by Sunday. So let's meet on Saturday then.